On the sun-drenched coast of South Texas near the vibrant city of Brownsville, a new chapter in space exploration is unfolding. This region, once known mainly for its tranquil beaches and warm Gulf breezes, is now at the center of a technological revolution that's capturing the world's imagination. Rising from the flat coastal plains is a futuristic landscape, Starbase, SpaceX's ambitious hub for building and launching the world's most powerful rockets. The facility stands as a testament to human vision and the relentless pursuit of progress, its gleaming structures visible for miles around. Here, teams of engineers and technicians work around the clock, united by a single audacious goal: reaching for the stars. Their dedication is evident in every weld, every bolt, and every late-night troubleshooting session, as they push the boundaries of what's possible. The current focus of all this energy and expertise is Starship Flight 11, a mission that represents a pivotal step in SpaceX's journey toward making humanity multiplanetary. This flight is more than just another test, it's a symbol of how far the program has come. Each new Starship is a product of constant evolution, incorporating hard-won lessons from every previous flight. With every launch attempt, the team refines their designs, learns from setbacks, and celebrates breakthroughs, making each mission a leap forward for the entire industry. Preparations for Flight 11 are nothing short of a spectacle, a symphony of modern engineering. Every test, every procedure, and every system check builds anticipation, as the world waits to see what this next chapter will bring. Starbase, now officially recognized as its own town, has become a landmark of human ingenuity and innovation. It's a place where the future is being built in real time, drawing visitors, dreamers, and experts from around the globe. The facility's massive hangars, intricate machinery, and the iconic launch tower, complete with its giant chopstick arms, set the stage for history. These structures are more than just metal and concrete. They are monuments to ambition and the spirit of exploration. As the world watches, the methodical final checks and thunderous engine tests serve as a powerful reminder of how far we've come and how much further we have yet to go. Each step is a blend of precision, risk, and hope. This flight isn't just a test, it's a bold demonstration of a new philosophy, rapid iteration, relentless progress, and the willingness to learn from every outcome. It's a mindset that's redefining what's possible in spaceflight. Now, as the countdown clock ticks closer to zero, the world holds its breath. SpaceX prepares to light the candle and send Starship soaring once more, pushing the boundaries of exploration and inspiring a new generation to dream even bigger. To truly grasp the significance of Flight 11, it's essential to understand what makes Starship so extraordinary. Starship isn't just another rocket, it's a bold leap forward, designed from the ground up to revolutionize how we access and explore space. SpaceX's vision for Starship is to create a fully reusable, next-generation spacecraft capable of carrying both crew and cargo to Earth orbit, the Moon, Mars, and beyond. When fully stacked with its super-heavy booster, Starship stands over 400 feet tall, making it the largest and most powerful rocket ever constructed. For comparison, it dwarfs even the legendary Saturn V and the Space Shuttle, setting a new benchmark in rocket engineering and ambition. But Starship's true breakthrough lies in its full, rapid reusability. Both the booster and the upper stage are engineered to return to Earth, land vertically, and be quickly refurbished for another flight. This is a radical departure from traditional rockets, which are typically discarded after a single use. This approach slashes launch costs dramatically, making space more accessible than ever before. It opens the door to frequent missions, large-scale exploration, and even the possibility of building permanent settlements beyond Earth, a dream that once seemed out of reach. Powering this giant are 33 Raptor engines on the booster and 6 more on the upper stage. These engines burn methane and liquid oxygen, fuels chosen not only for their efficiency, but also because they can potentially be produced on Mars, enabling future missions to refuel on other worlds. Starship's immense size, rapid reusability, and advanced propulsion systems represent a paradigm shift in spaceflight. This new approach promises affordable, frequent flights, and lays the groundwork for humanity's journey to other planets. Every test flight, including Flight 11, is a crucial step in refining this revolutionary system. Each launch brings new data, new lessons, and new confidence in the technology. As teams at Starbase work tirelessly to assemble and test each component, we're witnessing the creation of the key to humanity's multiplanetary future. The scale and ambition of this project are unlike anything seen before in aerospace. Starship is more than just a rocket, it's the foundation for the next era of exploration, a symbol of what's possible when innovation meets determination, and a beacon guiding us toward the stars. One of the most striking sights at Starbase is the slow, deliberate move of Starship to the launch pad. On September 17th, the gleaming upper stage for Flight 11 rolled out under the bright lights, a testament to its immense scale. Specialized transporters and a dedicated team ensure its safe arrival at the towering launch structure. The launch tower's robotic chopstick arms then lift the massive spacecraft, a breathtaking display of precision engineering. This careful dance is a critical milestone marking the transition from assembly to final ground testing. For Flight 11, reaching the pad signals the true start of the countdown. Each successful lift brings the team closer to launch, highlighting the respect and care behind every step. With Starship in place, the final phase of checks begins, setting the stage for another leap toward the stars. Once Starship is at the pad, it faces a gauntlet of tests to prove its readiness. These tests are designed to push the vehicle to its limits, ensuring every system is robust enough to handle the extreme conditions of launch and spaceflight. Each step is critical and nothing is left to chance. First comes the cryogenic proof test, where tanks are filled with super-chilled liquid nitrogen to simulate flight conditions and check for leaks. This process is vital, as it exposes the tanks to the same thermal stresses they'll experience in space. Engineers closely monitor for any signs of weakness or structural issues, knowing that even the smallest flaw could jeopardize the mission. Next, the focus shifts to the 6 Raptor engines, which undergo a series of pre-burner and spin prime tests to verify their complex systems. These tests ensure that the engine's pumps, valves, and combustion chambers are all functioning perfectly. The Raptor engines are among the most advanced ever built, and their reliability is essential for a safe flight. The climax is the static fire. Engines ignite while the vehicle is bolted down, shaking the ground and providing crucial performance data. This is the moment when all systems are tested together under real conditions, and engineers analyze every detail, from thrust levels to vibration patterns, to ensure everything is within safe limits. Both the upper stage and Super Heavy booster must pass these rigorous tests independently before stacking. Each stage is treated as its own spacecraft, with unique challenges and requirements that must be met before they can be joined for flight. The booster's 33 engines face an even more complex series of checks. With so many engines working in unison, engineers must verify that every single one performs flawlessly, as a single failure could affect the entire mission. Each successful test is a green light, confirming the hardware is ready for the next phase. These milestones are celebrated by the team, marking progress toward launch and building confidence in the vehicle's capabilities. This painstaking process builds confidence in the vehicle and ensures launch day success. Every data point is scrutinized, and every checklist item is double-checked, because the margin for error is zero. It's the unseen work that makes the spectacle of launch possible. Behind every dramatic liftoff are countless hours of preparation, testing, and teamwork, all dedicated to making spaceflight safer and more reliable than ever before. The most powerful ground test at Starbase is the Super Heavy booster's full static fire. On September 7th, all 33 Raptor engines ignited, unleashing a controlled inferno and a ground-shaking roar. Engineers monitored thousands of data points, ensuring every engine performed in harmony, and the launch pad's water deluge system held strong. This test proves the booster and its infrastructure can handle the immense forces of launch. The successful static fire for Flight 11's booster was a major milestone, clearing the way for stacking. It's more than a spectacle, it's a rigorous proof of capability. With this test complete, the booster was declared ready for flight. Starship's rapid progress is built on learning by doing, and Flight 10 was a breakthrough. Launched in August, it was the year's 4th Starship flight and the most successful yet. Key milestones included the flawless hot staging maneuver and the first deployment of mock Starlink satellites from Starship's bay doors. The mission also saw a Raptor engine reignite in space, a critical step for future Moon and Mars landings. Both stages achieved their objectives, with controlled water landings proving precise navigation. These triumphs provided invaluable data and boosted confidence in Starship's reliability. Lessons from Flight 10 have been directly applied to Flight 11, setting the stage for even greater achievements. Flight 11 is the final mission for Starship version 2, capping a year of rapid progress and hard-won lessons. It's the last chance to validate this design before SpaceX shifts to the taller, more capable version 3. Version 3 promises greater payloads and ambitious missions, including potential uncrewed Mars launches as early as 2026. Flight 11's success is also crucial for NASA's Artemis program, which relies on Starship to land astronauts on the Moon. NASA is watching closely, as this mission will influence timelines for America's return to the lunar surface. Flight 11 is more than a test. It's a bridge to the future, closing one chapter and opening another. Its outcome will ripple through both NASA's plans and SpaceX's Mars ambitions. This is the final exam for version 2, unlocking the next era of exploration. The relentless pace at Starbase is reshaping our relationship with space. Each test and flight is a step toward a future where humanity is multi-planetary. SpaceX's rapid, iterative approach treats rockets as machines to be perfected, not monuments to be preserved. Starship's reusability promises affordable access to orbit, opening space to new industries and opportunities. Regulatory changes are clearing the way for faster innovation, accelerating our return to the Moon and first steps on Mars. Every launch from Texas is part of a grander vision, turning science fiction into engineering fact. The preparations for Flight 11 are the latest chapter in this story of progress. The thunder of Starship's engines signals a new age, where the sky is just the beginning.